Good day and dangal greetings. Welcome to this YouTube video presentation, and I am James Yuan Dalmacio, the leader of this group. So here in this video, we will be presenting our project titled Quickmart POS system. So this is a Java-based point-of-sale system developed using Java Swing, designed for small retail stores to manage products, handle transactions, and generate receipts. Our system allows the cashier to select products, input quantity, and add items to a cart, and automatically compute the total amount. It also demonstrates object-oriented programming principles and uses design patterns such as singleton, observer, and factory. Now, to better understand how our system is structured, let's, let's first take a look at our UML class diagram. So this diagram shows the overall structure and relationships of our system. Here we have the product class, which is an abstract class. It serves as the base class for all product types in our system. From this, we have three subclasses: beverage, household item, and snack. These demonstrate inheritance, where each subclasses extends the product and adds its own unique attributes. On the right side, we have card which follows the singleton pattern, meaning only one instance of the card exists during runtime. The card also implements the observer pattern, where it not a POSFrame, where whenever there are changes in the card, such as adding or removing items. We also have the product factory, which is responsible for creating product objects by name dynamically. This follows the factory pattern. And lastly, the receipt generator. It is used to generate the final receipt after checkout. And overall, this UML diagram shows how our system is modular, organized, and follows proper object-oriented design. Now, let's focus on the product class. The product class plays a central role in our system because it serves as the base or blueprint for all products. All product types such as beverages, snacks, and household items inherit from this class. So here in our code, as we can see, we define it as an abstract. This means that it cannot be instantiated directly and is only used as a parent class. It contains common attributes shared by all products, such as private string product ID, private string name, double price, string category, and int stock. So these attributes are declared as private to implement encapsulation and ensuring that they are accessed through controlled methods. So for example, we use getters like public string get product ID. The product class also manages the stock through this method. So we have method like reduce stock. If quantity is greater than stock, it will throw an illegal argument exemption of not enough stock for product. And another method such as restore stock with a parameter of quantity. And finally, we define an abstract method. So the public abstract string get description. So this method forces all subclasses to implement their own description, demonstrating abstraction. So that's all for the product class. Let's go to the subclasses of this product class, which is the beverage class. So the beverage class represents all beverage products in the system. Its role is to extend the product class and add specific attributes that only applies to beverages. So in the code, we define private boolean is cold. So these attributes indicates whether the beverage is served hot or cold. We also override the description method. Here we use a conditional operator to display additional information. This demonstrates polymorphism since the method behaves differently for these subclasses or for this subclass. And next we have the household item class. So this class represents household products such as detergents and soaps. Its role is to extend the product class and include additional information specific to household items. So in our code, we define private string brand. This allows us to identify the product's brand. We also provide a getter method like public string get brand, and we override the description method. And this also enhance the product description with more specific details. And finally, the last subclass of the product class is the snacks. The snack class represent the snack products in the system. Its role is to extend the product class and include attributes that describe snack-specific properties. So in our code, we define private double weight grams. This represents the weight of the snack product. Similar to other subclasses, we override the description method, public string get description, return snack get name and the wet grams. This allows us that to each snack product to display its weight in the description. And overall, this demonstrates inheritance and polymorphism in our system. So now that we've discussed the role of the product class and its subclasses, Rex will now explain how these products are created dynamically and how the system manages them using the product factory and other core components.
Thank you for the explanation, Mr. Dalmacio. Now, let's start with product factory class. The product factory class has the basic instruction logic from the rest of the program. Instead of joining new beverage or new snack directly all over our program, we all one single method, which is the product factory that creates product. Instead a type string like beverage, snack, or household, plus the open product details. The extra parameter is a variance array that handles like specific data. Inside, there's a switch statement. For a beverage, it reads extra 0 as a boolean, true means cold, false means hot. For a snack, it parses the weight in grams. For a household item, it reads the brand name. If you pass an unknown type, it throws an illegal argument exception immediately. The POSFrame doesn't need to know which half does in instant case. It just says, give me a beverage, and the factory handles the rest. This makes the old easy to extend to as a new product type. It just adds a new case to the switch statement. Next, the art that will be explained by Mr. Consorte.
So thank you for that, Rex. Now, let's move on to the card class of our Quickmart system. We start with the singleton pattern. So by using a private constructor and a static instance, we ensure that only one shopping cart exists during the user session. The get instance method is the only way to access it, creating the cart if it doesn't exist yet. So our cart manages two lists, one for the items and one for the observers. To allow our UI like a checkout total or a cart badge to respond to changes, we use the add observer method to register them. Whenever we change the cart state, we call the private notify observers method, which loops through that list and tells every observer to update. Now for the heavy lifting. Add item. This method does three things. First, it validates stock. If the user wants more than what's available, it throws an illegal argument exception. Second, it checks if the product is already in the cart. If it is, it just increases the quantity and reduces the product stock. So if it's a new product, it creates a new cart item entry. In both cases, we notify our observers immediately. So managing the cart also means managing inventory. In remove item, we take a specific index. Find the item and call restore stock to input those items back into the store's inventory before removing the entry. The clear cart method does the same thing, but on a larger scale. It loops through every item to restore the stock and then wipes the list clean. Again, both trigger a UI notification. To get data out of the cart, we use get items. We return a defensive copy, a new list, so that external code can't modify our internal list without going through our method. For the checkout math, get subtotal iterates through all items and sums up their individual costs. Get tax calculate a 12% VAT based on the subtotal, and get total simply adds those two values together for the final price. So finally, we have two quick utility method. Is empty, which helps the UI decide whether to show the proceed to checkout button, and get item count, which returns the number of unique items for the cart icon. So every method in this class is designed to keep our data consistent, our inventory accurate, and our user interface perfectly in sync. So now let's move on to the next class. So now for the cart item class. So while the cart manages the overall list, the cart item class is the fundamental building block of our shopping system. Its job is simple but vital. It links a specific product with the quantity a user wants to buy. Instead of the cart just holding a list of products, it holds a list of these cart item objects. The constructor here is straightforward. It takes a product object and an integer for quantity and initializes them. So by using private fields and public getters like getProduct and getQuantity, we ensure the integrity of the data. Other classes can see what's inside, but they can change the product itself once the item is created. We also have a set quantity method. This is important for when a user decides to add more of the same item or reduce the amount from their cart view. It allows the cart class to update the amount without having to delete and recreate the entire object. So finally, we have the get subtotal method. This is where the local math happens. Instead of making the main cart class reach in a grab price manually, the cart item calculates its own cost by multiplying the product's price by the current quantity. This follows the principles of encapsulation. The object responsible for the data is also responsible for the calculations related to that data. This makes our code much cleaner and easier to maintain. So now, let's move on to the next class. Now, for the next class, which is the cart observer class, so to bring our observer pattern to life, we have the cart observer interface. Think of this as a construct or a set of rules. Any class in our system that wants to watch the cart, whether it's a sidebar, a checkout counter, or a notification badge, must implement this interface because it contains just one method on cart updated. So by keeping this interface simple, we achieve what we call loose coupling. The cart class doesn't need to know the complex details of how the UI works. It only knows that if an object is a cart observer, it has this specific method ready to be called. When the cart changes it shouts out to all its observers, and they execute their own unique logic inside this method. Now that we've covered the three class and the design patterns that keep our cart synchronized, it's time to see how this all looks for the user. To explain how we transition from this code structure to the actual POSFrame, I'll turn it over to Rex de Gracia.
Thank you for the explanation, Mr. Consorte. Now, I will explain the post-frame class. First, the class declaration. Two things are happening here. It sets J-frame, meaning this class is a window, and it implements start observer, meaning it applies to the arc and will automatically react whenever the arc changes. That's the observer pattern at work. Now, the fields at the top we have private final chart equals chart that gets instant. Private list products. Chart that gets instant uses the singleton pattern. There is always exactly one chart in the entire explanation. Entire application. And post-frame graph is here. The product list will hold our all inventory. Then we have all the GUI components with JList, JTable, JSpinner, labels, buttons, and category, JObobox. These are declared as the class level, so every method in the class can access and update them. Then, the constructor sets up the window and keeps everything up. Line by line, we have the window title. That is to fully exit the app when closed. Fix the size at 850 by 600 pixels. Center it on screen and lock resizing. Then the setup sequence. In this product, load the product catalog, chart that adds observer list, register POSFrame as a listener to the arc. Build UI, construct all the panels and components, and then clean refreshes and make sure everything displays correctly from the very first frame. Then, the init product method. You populate the product catalog using factory pattern. Instead of calling new beverage or use snack, directly with the product factory, the right product handle it. The first argument is the type pattern with the ID, name, price, stock, and the type specific extra value, like true for all beverage, grams for snack, or the brand name for household items. Clean, consistent, and easy to extend. Then, the build UI method is the master layout method. It doesn't create any opponents itself. It just assembles the panel built by the other method. The layout is a border layout. The header goes to the north. The center is a J-split pane, a horizontal divider that puts the product panel on the left and the arc panel on the right. Split at 320 pixels. The bottom panel with totals and bottom goes to the south. The build header panel method. The build header panel method creates the blue bar at the top of the window. It's a simple border layout with a blue background. The up title is on the left side and the affirmation is on the right. White and light blue text is without link, no special look, nothing of the excess, just a visual structure. Then, the build product panel with the entire left side. The category filter, the product list, the quantity screener, and the add to art button. The J-Combo box has 4 options: all beverage, snack, household, and action listener are every time the selection change. Holding refresh product list to filter was shown. The product list the product list uses a default list model, a dynamic data model that the JList returns. The selection listener holds up the stock label whenever the user selects a different product, but only when the selection is fully settled. That's what the value is adjusting your agency. Then, the spinner uses a spinner rubber model. Minimum 1, maximum 100. F size 1. The add to art button triggers add to art will hover shortly. Then, the build chart panel method. The build chart panel method is the right side. The shopping chart table and the remove button. The table uses a default table model with 5 columns. Notice the anonymous slash override is held editable. Always returns false. Make the table read only. Users can just click into a cell and type. All hard modifications go through the button only, keeping the data integrity intact. Column widths are set manually for a balanced, readable layout. The product name is the most space quantity in the list. And the remove button is tile press using share tile button, helper, and where to remove from chart. Then next is the build bottom panel. Build bottom panel raise a bottom bar, have total but total on the left and the near heart and the checkout button on the right. The totals use a 3x2 grid layout. 3 rows for subtotal, but and total, with a label on the left side and a knife value on the right. These value labels are stored as fields, so update totals and update them later. The checkout button is slightly larger and bold to start out as the primary action there. Therefore, uses orange, checkout uses blue, color community is intent. Then, make label method and style button method. These two are both utility methods that give the UI code clean. Make label method is a one-liner factory for labels, just able repeating new JLabel followed by set font every time. The style button method applies a consistent look to every button. Background color, text color, no active POSFrame, no default border, bold font, and a hand cursor on hover. All four buttons in the app uses this method. Then, the refresh product list method. The computates the JList based on the select category. It clears the model first, then iterates through all the products. If the category is all, or the product category matches the filter, it adds a display string. The product label that is current stock count in brackets. Selection is there and the stock label resets to dashes, so there's no stale data showing. Then, just filter product method. Just filter product is a helper that returns just the product when visible in the list. Based on the active category filter, this is critical because the JList shows filter subset of products. When the user clicks index 2 in the list, that index maps to the filter list, not the full product list. This method ensures AutoR and update stock label always drop the correct product. Next is the update stock label method. Shows the current stock of whatever product is selected. It's just the selected index finds the matching product in the filter list and updates the stock label. The order changes to if stock is below 5, it turns red as a warning. Otherwise, it's trimmed, bold size, but very helpful for a year. Then, the AutoR method. The AutoR handles what happens when the user clicks AutoR. First, it checks that something is actually selected. If not, it shows an error and returns error. Then, it checks the product using just filter product. With the spinner value, shows chart.item. If the R throws an exception, say because stock is insufficient, it catches it and shows the error message to the user. After a successful add, the spinner resets to 1. Then, the remove from chart method. It reads the selected row index from the J table. If nothing is selected, it shows an error. Otherwise, it passes the index to chart.remove item. The R handles restoring the product stock. and the observer notification triggers the UI refresh automatically. Then, the other char method. If the arc is empty, already empty, there's nothing to do. Only return otherwise a yes or no dialog appears. You never want a user to accidentally wipe their entire chart with one click. If they confirm, start the new chart is told, which restores all stack and triggers the observer to refresh everything. Then, the checkout method. If the arc is empty, if the checkout with an error, otherwise it calls the receipt generator that generates chart suggest the formatted receipt string. Then wrap it in a non-editable data area inside a JSON pane and displays it as a dialog. Bonus space font is used for the receipt volume select perfectly. Just like a returnable receipt, after the user closes the dialog, start the new chart presses everything for the next customer. Then the next is show error. The show error method is a one-liner utility that pops an error dialog. It's used in 5 different places across the class. Having it as a method means if you ever want to change how errors are displayed, say a custom dialog, you change it in one place. Then, on chart updated method, refresh table method, update total method. These three methods are the observer pattern in action. On chart updated method is called automatically with the arc every time anything changes. Intelligence for three methods. No manual update calls needed. Anywhere else in the code. Refresh chart table method with the entire rows with have round count and reveals it from the orange chart items. Each row is an object array matching the 5 column headers. Update total refreshes all three money labels. Subtotal with path, and the final total formatted to 2 decimal places with peso sign. And that's every method in the POSFrame. The next class will be explained by Mr. Escueta.
Hello everyone, my name is Caistler Joseph Escueta, and I'll be the one explaining the receipt generator class, main class, and I'm gonna demo our output. So let's walk through the receipt generator class. So this is a utility class. It doesn't extend anything or implement an interface. Its sole job is to take the current cart and format a readable receipt string. So notice three things. So first is the transaction counter is a static field. It persists across calls and auto increments, giving each transaction a unique ID. So second is we use local datetime that now with a datetime formatter for a formatted timestamp. Third, the class delegates all financial logic to the cart. It calls get subtotal, get tax, and get total. Receipt generator only handles presentation. So next one is let's move on to the main class. So this is our entry point. It's intentionally minimal. Its only job is to safely launch the Swing GUI. Let's walk through each line. So Swing utilities that invoke later is crucial. Swing is not a thread shape. So all GUI operations must run on the event dispatch thread. So we wrap everything in a BDA passed to this method. Inside, we call UI manager that set look and feel so that app uses native OS styling. Then we simply instantiate POSFrame, which handles everything else like products, card setup, observers, and call set visible to true to show the window. So next one is I'm gonna show you what's the visual of our output. So as you can see, we have this window as our project. So let's try to add to cart 5 quantities of this Coca-Cola. 65 times 5 is equals to subtotal of 325 pesos. And when we check out, the receipt will be shown from the last class. As you can see, I explained how receipt generator works, and this is the output of the receipt generator class. So let's try to add another. We can also clear cart after adding many items. So you can see, as when we clear the cart, the items will be removed. Let's try to remove selected. As you can see, the mineral water or Nescafe 3 in 1 is removed. So let's try to remove the Milo, and then we check out. This is the receipt I have made. So the singleton, to wrap up, Quickmart POS is more than just a functioning store system. It's a demonstration of how object-oriented programming principles and design patterns solve real problems cleanly. So the singleton patterns ensures a single, consistent card state through the session. The factory pattern hides object creation. Callers don't need to know whether they're getting a beverage, snack, or household item. The observer pattern decouples the cart from the UI. The cart never directly touches any label or table. It simply notifies its observers, and the abstract product class enforces a contract through abstraction and inheritance, while encapsulation protects stock values from being modified arbitrarily. So these aren't just concepts from a textbook. You can see every one of them running live in this system. So each class has one clear responsibility, and together they form a program that's maintainable, extensible, and easy to reason about. So that's the value of object-oriented programming. That concludes our presentation of QuickMart POS. We're happy to answer any questions about the design decisions or implementation details, sir. Thank you so much. That's all.